I would like to begin by doing a brief introduction to vector product. And suppose we have two vectors, A defined as follow, the components A1, A2, and A3, and another vector B, components defined B1, B2, and B3. And so we define the vector product as follow. This is a vector product. We use a cross to differentiate between differentiate from a dot product, and the outcome is another vector. So the main difference of vector product, you get another vector. And the way we write is that to find it is like this. We will find the determinant. If you recall matrix, something about matrix, and this is you probably have learned how to find determinant of 2 by 2 matrix like this. In this case, we'll be looking at a 3 by 3 matrix. In the second row, you put because we started with A, so second row we put the component of A here, and the third row, because we ended the product with B, we put the third row the components of B. That's the definition. There's another simpler way to do this, because a 3 by 3 determinant is not easy to find. So we have a formula to help us to remember this. And of course, you can write this down in your reference sheet for when you want to go for assessment. And of course, this is in IJK form, and so you can also express it as follow. So if you know your A, B, and A1, A2, A3, and B1, B2, B3, you can calculate like that, right? So this is from a 3 by 3 matrix. That means determine a 3 by 3 matrix. You finding the determinant of a 2 by 2 matrix, which is some much more easier. You can use this or use this, up to your preference. And so there is another quicker way. I don't really have a name for it, but suppose you don't want to memorize this, there's a way for you to do it. Sometimes I call it crisscross or whatever. So what you do is you have a cross B. You put the IJK here, and you will have the A1, A2, A3, B1, B2, B3. This is by definition, so we just follow the definitions. And what you do is now you copy this column here, A2, A1, B1, and then the second column, we copy second column, J, A2, B2, and we do something like this. We multiply this, find the product of this, find the product of this, find the product of this, and then we get something. So the product sum is find the sum of it, the product of each of these 3 diagonal, you might say it, and then subtract this, take and find the product of this, this, and this. Then you get the first diagonal plus the second diagonal and plus the last diagonal, and when you simplify it, you get the vector that you want. So I will use examples to illustrate how you use both methods. I mean, this is by formula, so pretty straightforward. So we move on here, use an example to talk about this. So start this, use question 1. So suppose I just let, for the sake of discussion, let A be 2, A3 1, and then B be 1, 4, A2. So what they ask you to calculate here is A cross B, basically. So if you're using the formula, right, if you don't recall, this is the formula here. You can take a good look. Okay, so you using, let me get back here. Okay, so if you're using a formula, then alright, okay, got it back here. That would be like this. Follow the formula. This is the A2 A3 is the A2 and A3, B2 and B3. So what I do is I put -3 here, 1 4 -2. The second component, right, this is like this, A3 B3, so A3 B3, so 1 -2 followed by 2 1. Okay, and next one is A1 B1, so it's A1 B1 2 1, and then A2 B2, so -3 4. So all I have to do is just perform the as if I calculating determinant. So this would be 6 minus 4. This will be 1 minus -4. This will be 8 minus -3, and I should everything fine, should end up with 2. Here it would be 5, and this is 11. So this would be my the cross product. Now how about the other way, what I just mentioned just now. So what you're going to do is you're going to arrange it. I need to be careful. I'll try to do my best to mention, explain it as clear as possible. So what I'm going to do is I'm going to copy in the second row the proper component of A, right? And then 1 4 -2. And now I'm going to copy the first column here, I 2 and 1, and the second column J and -3 and 4. Okay, you be careful there. So we'll start by doing this cross product, something like this. So I take I times -3 times 2. So I will have 6, right? 3 times 2, we will have -6. I have 6i. Okay, and then move on to this one. I have j times 1 times 1. I will have 1j. So I plus j. Okay, I do this, and then the next one I end with this for the first run of the product. So I use a k times 2 times 4. That is 2 4 8 8k plus 8k. Let's follow. Put in brackets to safeguard my calculation. Subtract. Right. Now I'm going to go from bottom up. So the 1 -3k, 1 -3k. So that would be -3k. And moving on. 4 1i, so 4 1i, that would be 4i. And lastly, this is -2 2j, so I have -4j. And so then I can just simplify this. I have 6i minus 4i, so I have 2i, and I have j minus 4j, so that means I get 5j, and 8k minus 3k, and that is plus 11k. And well, it is essentially the same as by using the formula. So you can try do part C or part B, whichever you like, and try this method. It's very efficient for a 3x3 matrix like this, or in this case the cross product. We'll see you in the next video, and all the best.